Wonderful. So if we have a list of classes, if it exists, we'll set the labels to equal classes. But if it doesn't, which is our current scenario, we'll set the labels to be just a range of our confusion matrix shape on the 0th axis, which is just 2. So it'll be 0 to 1. Wonderful. And now let's label the axes. Ax.set, because we're going to be writing a bunch of labels here. We're just going to use the shortcut ax.set from matplotlib. Confusion matrix, that's a title. And remember, we're prettifying it so it looks like this. That's our title, this is our X label, this is our Y label. So these are the ones that we need. X is the predicted label, and then Y label equals true label. Wonderful. We're also going to set up the X ticks to be NPA range and classes. And then the Y ticks is going to be the same thing, NPA range and classes. That's the number of little dashes that we want to have on our figure. We'll see what that looks like in a second. We can also set the X tick labels to be our labels variable, which in the case of binary classification, it's just going to be the range. We don't have a list of class names. The labels are just going to be the class integer values. And same thing for the Y tick labels, equals labels. We need to set the threshold for different colors. This will make sense in a second. So the threshold equals cm.max, so the max value in our confusion matrix, plus the minimum. And then we want to divide that by 2. That's the threshold. So this is going to give our confusion matrix different shades of squares depending on how many values are in there. So a typical confusion matrix is you want the diagonal axis to be really dark where the correct predictions are, and all of the other ones where there's not many prediction values to be light. This will make a lot more sense when we visualize our pretty confusion matrix. So we're going to plot some text on each cell. So we can go for I, J in iter_tools. So iter_tools is going to iterate through whatever we pass it. So we want range, cm, shape, 0. And same thing for range, cm, shape, 1. And we go boom, plt. Now this is, we're going to set the text for each square. So ji, this is giving ourselves coordinates. And then we can set up an f string through our confusion matrix for ij coordinates, ij index, that is. We want that. And then it's also going to be, and we want in brackets, cm norm, again the same locale index, times 100. We want 1 decimal point here, f, and then squiggly bracket, fix up the f string, and percentage. Oh, our bracket's correct here. Fingers crossed. There's going to be an error here somewhere, isn't there? Let's convert it back here. Where have we got an extra? We want this to be the same color. Okay, wonderful. Yep, that should be like that. Oh, our F string has ended too early. That's what we want. Wonderful. Now we can have a little comma after that. We want horizontal alignment equals center, and then we want to go color equals white. This is going to be the color of the text. If our confusion matrix at a particular index is greater than the threshold, else we want the text to be black. Wonderful. And the size can be 15. There's a fair bit going on here, but again, if you're not sure what's happening in any of these lines, remember, break it apart. We've got a lot going on here. It took me a while to remix this function here, so I didn't just pull this out of the hat. Let's see what it looks like anyway, see where our errors appear. Wonderful. Text has no property, horizontal alignment. Up on the end. There we go. Woo! So we basically just replicated our pretty confusion matrix. See what I meant with color threshold here? We want our squares with lots of values in them to be darker, and the squares